To keep pace, the speed of modern cyber threats requires an entirely new operational framework, the 1-5-10 architecture. This is a strict quantitative target for enterprise resilience. 1 minute to detect an intrusion, 5 minutes to triage the threat and find the root cause, 10 minutes to fully recover. Human operators cannot hit these metrics manually. Reaching minutes to seconds response times requires handing operational control to autonomous agentic AI systems. But that delegation introduces a concrete operational paradox. Deploying autonomous AI immediately creates opaque visibility blind spots within the enterprise network. When an AI agent takes an action, traditional security logging tells you exactly what data moved or what script ran. It provides no information regarding the reasoning process that led to that decision. If an organization wants to hit the 1-5-10 target, it must supplement traditional security with observability designed to audit the AI itself. Modern security has moved away from the legacy focus on perimeters and signatures. The current operational standard is an assume breach posture. This shift requires passive observability. Instead of writing static rules for known bad actors, organizations deploy AI software that continuously learns normal network baselines. Once the AI understands normal traffic patterns, it detects abnormal behavior without relying on pre-existing threat signatures. Feeding a baseline model at this scale requires hardware capable of massive data retention, specifically full packet capture arrays recording all network communications. Legacy alert systems miss the unknown unknowns. By recording full packet data, security teams can retroactively investigate zero-day threats long after the initial event. Proactive defense relies on possessing complete historical context to investigate exactly what the AI flags, rather than just reacting to known alerts faster. Before AI can defend a network at speed, the enterprise has to solve the visibility silo problem. In a typical enterprise, network operations and security operations function in isolation. A compromised Wi-Fi router might generate an alert in the NOC ticketing system, but that data never reaches the SOC. AI serves as the correlation engine, stitching these segmented telemetry streams together into a single timeline. The data converges in a unified dashboard. A centralized AI risk advisor layer ingests both operational network uptime and security threat intelligence, analyzing the combined data flow. Within this unified environment, an analyst can trigger an AI-native playbook to isolate a compromised node in seconds. With normalized data flowing into a single hub, the security posture shifts. Analysts stop firefighting daily alerts and use the combined data to predictively model where vulnerabilities will emerge next. Without converging NOC and SOC data streams, AI defense systems are effectively fighting blind across half the enterprise infrastructure. Traditional CM logging provides the timeline of what happened, but it cannot explain the logic that drove an autonomous agent's actions. Standard CM logs track system events like IP addresses and timestamps, but when an AI decides, security teams must know the reasoning. Autonomous workflows are vastly more complex. Input data flows into a black box processing layer that outputs cascading tool calls. Auditing this requires action transparency. The infrastructure must log every single API call the AI agent makes. It must record the exact data sources the agent queried and the external scripts it executed before reaching its decision. This level of tracking is necessary to detect intent drift, a behavioral risk specific to autonomous operations. An agent might start with a legitimate task, but gradually deviate mid-session, looping endlessly or misusing tools in unusual sequences. The limitation is the processing layer. Current LLM architecture is a black box. Security teams cannot directly observe the internal reasoning of the model. The workaround requires rigorously capturing the exact inputs provided to the agent at the exact moment of decision. Security teams must also record the alternative options the agent weighed and rejected before executing its final action. Deploying AI without reasoning traces creates an environment where machines execute actions humans can neither reconstruct nor hold accountable. AI systems degrade through model collapse. If an AI continuously trains on its own outputs, the quality of its decisions warps and degrades over time. Preventing this degradation starts with aggressive discovery. Governance teams must continuously scan the network to inventory shadow AI tools and unapproved models. Outright banning AI tools fails because employees simply hide their usage. As seen in recent corporate data leaks, Organizations must monitor network traffic and API calls to control usage without killing productivity. Even approved tools carry risk. Security expert Alex Stamos notes deploying an unsupervised agent for hours leads to context window degradation and task drift. Organizations prevent this by implementing strict session management. They break complex objectives into small, specific subtasks to prevent the agent from hallucinating or drifting off mission. Frameworks like ISO 42001 provide a baseline, requiring organizations to implement continuous runtime security monitoring and scan models before deployment. This shifts the role of human analysts. With AI replacing Tier 1 triage, Tier 2 and Tier 3 analysts now serve as the observability layer for the AI itself. Analysts operate in a human-in-the-loop feedback cycle. They audit the AI's recommendations, querying the system's reasoning in plain language to correct its course. A secure AI system requires an artificial incentive structure. Constant human measurement and auditing are the only way to prevent dependency failures. The 1-5-10 architecture succeeds when integrated. The dashboard relies on passive baselines, unified telemetry, and human validation. When a novel threat hits, the baseline instantly flags it. The agent evaluates data, generates an auditable reasoning trace, and neutralizes the threat inside the unified dashboard. The core principle driving modern security is that AI visibility and cybersecurity visibility are the same problem. The massive volumes of data fueling the AI's operational intelligence are the exact same data points that create the organization's ultimate risk. Survival in modern automated enterprise networks requires building infrastructure designed specifically to audit the autonomous systems we deploy. Blind trust in AI is a critical vulnerability. Rigorous end-to-end observability is the ultimate defense.